Ballast water, pumped into a vessel's ballast water tank, provides stability. Untreated ballast water, if discharged along with the organisms, could cause irreversible loss of diversity in marine ecosystems. Alfa Laval Pure Ballast 3 is the third generation of the leading ballast water treatment technology. Pure Ballast 3 offers efficient energy performance and simple, chemical-free operation with full automation. What's more, Pure Ballast 3 is both US Coast Guard and IMO type approved. In this module, you will learn more of the Pure Ballast 3 Standard and EX models. Welcome to this e-learning module on Pure Ballast 3, Introduction to Standard and EX. This module will take you approximately 90 minutes to complete. The module is in English. Click Begin to start the module. Let us take a quick look at how you can navigate through this module. Click Next to continue. This module has 6 topics. We recommend that you view these in sequence. To successfully complete this module, we request you to pass the assessment in the end of the module. Click on each topic to learn more. This training will help you operate the Pure Ballast 3 system in a way that complies with the legislations regarding ballast water management. Describe the ballast water treatment process and the functionalities of the system components. Describe how the Pure Ballast 3 system can be integrated into the vessel. Recognize the optional components that are available and how they facilitate operation. Identify how to navigate the control panel. Identify how to start a process in Pure Ballast 3. Did you know that ballast water contains thousands of organisms which could potentially harm the environment? So, why is a ballast water treatment system needed? Let's find out. Untreated ballast water, if discharged along with the organisms, can outcompete, displace or kill native species, causing irreversible loss of diversity in the world's marine ecosystems. As a consequence, over hundreds of such invasions have already taken place. Here, take a look at this map that shows the impact of an invasive species, the European green crab. Known as one of the top 100 worst invasive species in the world, the green crab has drastically reduced the population of native species when introduced in waters. Not only has it threatened coastal ecosystems, it has also affected the local human populations they support. The red and green areas marked in this map show invasion in different regions. Click Next to continue. To minimize the transfer of invasive species, regulations for ballast water treatment are in force at international, national and regional levels. 2 of the most significant regulations are those of the International Maritime Organization, or IMO, and the United States Coast Guard, or USCG. However, other nations and regional authorities have also set their own requirements. Click on each icon to learn more. One difference between the IMO and US Coast Guard discharge standards is the testing and verification methods used to measure the effectiveness of the ballast water treatment system. The IMO evaluates the number of organisms that can reproduce. If the organisms cannot reproduce, they do not pose a threat of becoming invasive. The US Coast Guard, however, evaluates how many organisms are living and non-living. Click Next to continue. The UV dose is the amount of light that the organisms are exposed to. The UV dose can be increased by either increasing the energy of the UV lamps or reducing the ballast water flow. A higher UV dose is needed to categorize the organisms as non-living directly after the discharge treatment, compared to rendering them non-viable. Thus, To optimize the performance of the ballast water treatment system, Alfa Laval's Pure Ballast 3 has two operational modes, IMO and US Coast Guard, adapted to the legislations. Click Next to continue. Holding time, sometimes also called hold time, is the amount of time that ballast water must be kept in the ballast water tanks after treatment. In other words, it is the time between ballasting and deballasting. Click on each logo to learn more. Under the IMO regulations, the organisms are rendered non-viable, so holding time is not needed. However, under the US Coast Guard regulations, holding time is required to render the organisms non-living. The holding time depends on the UV dose that the water is treated with. While a higher ultraviolet dose will require a shorter holding time, a lower ultraviolet dose will require a longer holding time. Click Next to continue. In the IMO mode, there is no holding time. This operational mode is used for ballast and deballast in all ports outside US waters. For US Coast Guard 0 days mode, the time between completing a ballast process and starting deballasting or stripping must be at least 2.5 hours. For US Coast Guard 3 days mode, the time between completing a ballast process and starting deballasting or stripping must be at least 72 hours. This operational mode is used for ballast when the ballast water will be discharged within US waters, regardless of the starting point. It is used for deballast within US waters. To learn more about what to consider when choosing between different modes, please refer to the e-learning course Pure Ballast 3 Operation. Click Next to continue. You have now come to the end of Topic 1, Introduction. Click Next to go back to the menu. Alfa Laval Pure Ballast 3 is an automated inline treatment system that disinfects ballast water using filtration and ultraviolet technology. Pure Ballast 3 is integrated in the vessel's ballast water system and treats the water during ballasting and deballasting. So, how does this process work? Let's find out. Click on each question to learn more. Pure Ballast 3 must be used during all ballast and deballast operations, except when ballast water is transferred internally between the ballast water tanks. The procedures concerning emergency and malfunction of the ballast water treatment system should be implemented in the ballast water management plan. Pure Ballast 3 works in all salinities, fresh, brackish and marine. A system can be configured for flows of 32 to 3000 meter cube per hour, and if larger capacities are needed, multiple systems can be installed. The components involved in the ballast operation outside of the Pure Ballast 3 system can be operated from the ship's control system or integrated with the Pure Ballast 3 system. This allows Pure Ballast 3 to send a request to be handled by the vessel's control system involving the ballast water pump, overboard valves, and valves leading water to or from Pure Ballast 3. Click Next to continue. Let us understand the function of the system components in greater detail. We will also look at how Pure Ballast 3 treats the ballast water. Click on each highlighted component to learn more. The system is certified according to ATEX and IEC-EX, Zone 1, LLC and T4. The cabinets are placed in the safe zone and the other components are placed in Zone 1. Click on the button to view the EX zones. For safety reasons, it must be possible to bypass the Pure Ballast 3 system in case of malfunction. The system must be equipped with at least one bypass valve, according to the BWM convention. The valve or valves must be controlled by the vessel's control system. All bypass valve activities are logged in the event log in Pure Ballast's control system. The ballast water taken up from the sea chest will first pass through the filter. The filter then removes larger organisms and reduces sediment in the ballast tanks. It is cleaned via automatic back-flushing using a small portion of the system flow, without interrupting the ballasting process. The filter is bypassed during deballast and stripping, since the water has already passed through the filter once during ballast. Click the play button to start the video.
Filtrex ACB is an automatic backwashing filter for water operated by electric power. Cleaning is performed using the filtered water with no interruption in the filtration process. The water enters from the inlet connection and flows through the wire mesh sectors of the filtering element. The water, filtered from inside to outside, exits through the outlet connection. During this phase, the filter operates as a static filter and the cleaning of the filtering element is inactive. As more and more impurities build up in the filtering element, the differential pressure gradually increases, as shown by the indicator, until the programmed set point is reached. Through the control panel, the electric motor is activated, then the backwash valve is opened, starting the rotation of the cleaning nozzle and the cleaning phase. While all sectors of the filter element ensure the normal filtration from inside to outside of the filtering element, the sectors in front of the rotating nozzle are rapidly cleaned one by one, with a reverse flow from drawn outside to inside of the filtering element. Thanks to the suction effect generated, the impurities are transported by the flow in the backwash line through the sludge duct and the backwash valve for disposal. At the end of the cleaning set time, the backwash valve closes and the motor stops, returning the filter to the static phase. The cleaning cycle is repeated every time the pressure drop reaches the preset value. The filtration process never stops.
The sampling device makes it possible to take samples of the ballast water to conduct tests that the Pure Ballast 3 system is performing according to the type approval certificate. Flow is monitored by the flow meter to ensure that the maximum allowed flow, that is, the certified flow, is not exceeded. Flow is monitored by the flow meter to ensure that the maximum allowed flow, that is, the certified flow, is not exceeded. The certified flow will be determined by the Pure Ballast model and depends on the process that is running. The latest version of Pure Ballast 3 uses a flow meter with an integrated conductivity sensor to determine the salinity of the water. In fresh water, more UV light is needed to fully treat the water compared to brackish and marine water. In challenging waters, the system will, therefore, reduce the flow to meet the UV transmittance (UVT) limits. This function is called the freshwater mode, and the status box in the control panel will show FW if it is active. The check valves are available only for the EX models. To ensure that there is water in the UV reactor when the lamps are lit, the system is equipped with a check valve before the inlet valve. The main treatment takes place in the UV reactor, where the water is disinfected using UV light. The UV lamps are protected by synthetic quartz sleeves. To save power, a UV sensor monitors the need for light in the reactor to avoid using more power than necessary. If the water clarity is low, the power is increased, and vice versa. The performance of the system is dependent on clean quartz sleeves, which allow the UV light to reach and treat the water. The SIP unit circulates a reusable, non-toxic and biodegradable cleaning solution that removes any scaling and dirt buildup that would prevent the UV light from treating the water. Click the play button to start the video. In a UV ballast water treatment system, the quartz sleeves protect the UV lamps in the reactor. The lamps are paired with UVI sensors, which measure the amount of UV light that passes through the seawater. If fouling or scaling occurs on either of these components, it can block the transmission of light and impact your compliance. That's where cleaning comes in. After each ballasting and deballasting cycle, Pure Ballast 3 pumps a gentle cleaning fluid into the UV reactor, made from a light citric acid. The fluid is biodegradable and completely safe to drain overboard. Once cleaning is complete, the reactor fills with fresh water until it's needed again. Unlike other methods, cleaning in place cleans not just the sleeves and sensors, but the entire reactor. And, since there are no chemicals, no manual operations, and no mechanical parts, it involves no risk to your Pure Ballast 3 system. The control valve regulates the flow, so that it does not exceed the certified flow. It will regulate the flow depending on the UV transmittance in the water, input from UV sensor, and the salinity, input from flow meter. The control valve also regulates the pressure during filter backflush, self-cleaning of the filter. The UV lamps are supplied with power from the lamp drive cabinet. In Pure Ballast 3, 1500 cubic meter systems will have a secondary lamp drive cabinet. The lamp drive cabinet include lamp power supplies, or LPS, which supply the UV lamp with power. The lamp power supplies also monitor the function of each UV lamp and react if a fault occurs. The lamp drive cabinet is equipped with a cooling system to maintain the correct operating temperature in the lamp drive cabinet and secondary lamp drive cabinet, using low temperature cooling water. A fan regulates the temperature in the cabinets. The humidity in the cabinet is monitored by a liquid sensor. If a leakage from the heat exchanger is detected, a warning is issued. The reactor is shut down, and the cooling water inlet valve to the lamp drive cabinet and secondary lamp drive cabinet is shut down. If a leakage from the cooling system occurs, it is detected by the liquid sensor. The cabinet is powered off, the UV reactor is shut down, the inlet valve is closed, and an alarm is issued. Pure Ballast 3 is monitored and controlled from a touchscreen in the control cabinet. You can also respond to alarms and export log files through the control cabinet. Pure Ballast 3 can also be controlled from the vessel's control system, ISCS, or a remote control panel. You will learn more about these options later in the module. The system is certified according to ATEX and IEC-EX, Zone 1, LLC and T4. The cabinets are placed in the safe zone and the other components are placed in Zone 1. Click on the button to view the EX zones. This section gives an overview of what options are available in terms of control system integration and auxiliary equipment. For detailed information regarding installation, please refer to the following design guides, which can be collected from your local Alfa Laval sales office. Pure Ballast 3 Design and Installation Guide, Remote Interface Implementation Guide, Pure Ballast 3 Connect Installation Guide, Logbox Installation Guide, Cybersecurity Guide. Click Next to continue. To facilitate the monitoring and control of Pure Ballast 3, it is possible to integrate the control system with other components on board the vessel. Such integrations using hardwired signal cables or Modbus communication will make the operation as easy as possible. The following integrations are available. Click on each icon of the control system to learn more. According to the BWM convention, all bypass configurations of the ballast water treatment system must be logged. The logbox monitors all bypass configurations and helps distinguish between an internal transfer, allowed, and bypass for operation, not allowed. Monitoring of bypass configurations can also be done via a remote interface or hardwired signal cables to the control system. To secure power for operation, Pure Ballast 3 can be integrated with the vessel's power management system. Individual components on board the vessel can be connected to the control system to open or close overboard valve and to start or stop ballast water pumps. The connectivity cabinet enables data transfer from the control system to be sent to Alfa Laval's web platform. In the web platform, it is possible to see the system performance and monitor the control system remotely. To allow operations from any place on board, up to 2 extra control panels can be installed. Pure Ballast 3 can then be operated from the bridge or the cargo control room. The control system can be connected to the GPS to retrieve coordinates on each event that is logged to the control system, together with time and date from the vessel's GPS. Common alarm or warning from the Pure Ballast 3 system can be integrated to the vessel's alarm monitoring system. If remote interface is integrated, Pure Ballast 3 can be monitored and operated from the vessel's integrated ship control system. With the external feed control, Pure Ballast 3 can request increased or decreased flow from the ballast water pump via a variable frequency drive, VFD. Alternatively, flow can be regulated by controlling a throttle valve before the system. External feed control enables smooth operation, especially during start and stop, reducing the stress on the control valve. Click Next to continue. After learning about the integration of the control system with the components on board a vessel, let us now explore the optional components of the Pure Ballast 3 system. Click on each highlighted component to learn more. Vacuum relief valves are installed when there is a large difference in height between the Pure Ballast 3 system and the ballast water tanks. The vacuum relief valves release the vacuum in the pipes, which can be harmful for the system and its components. Vacuum relief valves are installed when the booster pump secures minimum flow in the backflush line during filter backflush. The booster pump secures minimum pressure at the filter inlet and is controlled via a variable filter drive, VFD. An air preparation unit is installed if the instrument air does not meet the requirements stated in the connection list in the system manual. It filters the air to make it clean and dry. The booster pump secures minimum flow in the UV reactor cooling water line during startup. A closed cooling unit is installed if the LDC cooling water does not meet the requirements stated in the connection list in the system manual. The cooling unit circulates a closed loop of fine quality water which is cooled with the normal seawater cooling system. Booster pump P4011 is included. The booster pump secures minimum flow in the LDC cooling water line. transformer is installed if the voltage does not meet the requirements stated in the system manual. Click Next to continue. You have now come to the end of Topic 2, System Components. Click Next to go back to the menu. The ballast water treatment involves the following processes: ballast, deballast, stripping, healing, sip process. Click on a tile to view the video and understand the process in detail.
Before you start a process, verify that there are no active alarms. The alarm symbol will turn red if there are any active alarms. IMO or U.S. Coast Guard mode must be selected by pressing one of the function buttons, based on which legislation that should be followed. If U.S. Coast Guard mode is selected, choose if 3 days or a 0-day hold time should be used. Refer to the manual for more information about what to consider when choosing between different modes. To start a ballast process, press Ballast. A pop-up will appear, requesting you to open valves to pure ballast so water can flow through pipes 201, 309, 403, and 404. These valves cannot be opened from the pure ballast control system. Open the valves and then press Confirm Open Valves. On some vessels, this is handled automatically. During the startup phase, the UV lamps are warmed up for 90 seconds. Cooling water is pumped through the UV reactor via pipe 403 to prevent overheating. A pop-up will appear, requesting you to start the ballast water pump. Start the pump, and then press Confirm Ballast Pump Started. On some vessels, this is handled automatically. This will stop the cooling and start the full ballast phase. Notice how the control valve is first set to 50% and then gradually opened to 100%. The flow will increase until the certified flow is reached, in this case 1,000 cubic meters per hour. This is done to get a soft start. The processed volume of ballast water can be seen here. The filter removes larger particles from the ballast water to enable an efficient treatment in the UV reactor. Over time, sediments will start building up on the filter. This will increase the filter differential pressure. When the differential pressure reaches 0.5 bar, the filter will perform an automatic backflush. The control valve will close a little to increase the pressure over the filter, and the backflush line 309 will open to flush the sediments overboard. As you can see, the backflushing does not interrupt the ballast process. To stop a ballast process, press Stop. An automatic filter backflush is performed to clean the filter. A pop-up will appear, requesting you to stop the ballast pump. Stop the pump and then press Confirm Ballast Pump Stopped. On some vessels, this is handled automatically. A pop-up will appear, requesting you to close valves to pipe 201, 309, 403, and 404. These valves cannot be operated from pure ballast. Close the valves and then press Confirm Closed Valves. On some vessels, this is handled automatically. A pop-up will appear, asking you if you want to run a SIP cleaning. A SIP cleaning process must be finished within the time stated in the pop-up. If no SIP cleaning is performed within the time limit, a warning is given. Operations after that will not be compliant. If a new process will be run within the time limit, press No. If not, press Yes to start SIP cleaning. A SIP cleaning takes about 25 minutes per UV reactor. If Yes is selected, the SIP cleaning will start when the UV reactor has cooled down. For more details on the SIP cleaning, refer to our other how-to videos. To start a deballast process, press Deballast. The deballast and ballast processes are similar, but in the deballast process, the filter is bypassed. This is because the water has already passed through the filter during ballast. When emptying the ballast water tanks, the main ballast pump will often lose suction before the tank is completely empty. By using an ejector or a stripping pump, the remaining water can be pumped out from the tanks. Before you start a stripping process, verify that there are no active alarms. The alarm symbol will turn red if there are any active alarms. IMO or U.S. Coast Guard mode must be selected by pressing one of the function buttons, based on which legislation that should be followed. If U.S. Coast Guard mode is selected, choose if 3 days or 0-day hold time should be used. Refer to the manual for more information about what to consider when choosing between different modes. In this case, we have a pure ballast system with two 1000 reactors, which gives the maximal flow of 2000. But due to low flow when emptying the tanks, only one UV reactor will be used during stripping. This means that the certified flow during stripping will be 1000. See parameter P171 to see how your pure ballast system is configured. To start a stripping process, press Strip. A pop-up will appear, requesting you to open valves outside pure ballast control. Open the valves and then press Confirm Open Valves. On some vessels, this is handled automatically. During the startup phase, the UV lamps are warmed up for 90 seconds. Cooling water is pumped through the UV reactor via pipe 403 to prevent overheating. When the startup phase is finished, a pop-up will appear, requesting you to start the stripping pump. Start the pump or ejector, and then press Confirm Strip Pump Started. On some vessels, this is handled automatically. This will stop the cooling and start the full stripping phase. Notice how the control valve is first set to 50% and then gradually opened to 100%. This is done to get a soft start. The current flow can be seen here. The filter is bypassed since the water has already passed through the filter during ballast. The processed volume of ballast water can be seen here. To stop a stripping process, press Stop. A pop-up will appear, requesting you to stop the stripping pump. Stop the stripping pump or ejector, and then press Confirm Pump Stopped. On some vessels, this is handled automatically. A pop-up will appear, requesting you to close overboard valves. These valves cannot be operated from pure ballast. Close the valves and then press Confirm Closed Valves. On some vessels, this is handled automatically. A pop-up will appear, asking you if you want to run a SIP cleaning process. A SIP cleaning process must be finished within the time stated in the pop-up. If no SIP cleaning is performed within the time limit, a warning is given. Operations after that will not be compliant. If a new process will be run within the time limit, press No. If not, press Yes to start SIP cleaning. A SIP cleaning takes about 25 minutes per UV reactor. If Yes is selected, the SIP cleaning will start when the UV reactor has cooled down. For more details on the SIP cleaning, see our other how-to videos. Ballast water that is transferred internally on board a vessel between ballast water tanks is not required to pass through the pure ballast system. However, a healing mode request must be sent to pure ballast, and the event will be logged in the control system. The healing mode request can either be sent from the vessel's control system or a log box. Healing mode can be requested when the pure ballast system is in standby or one of the processes: full ballast, full deballast, or full stripping. During healing operation, the operator is responsible to ensure that overboard valves are closed to prevent unintended discharge. This video will show what happens when healing is requested in standby and full deballast. In this example, healing is requested when the system is in standby. A warning will be issued, notifying that healing mode has been requested. Press AC All to acknowledge the warning. Pure ballast is now in healing mode and the system will be bypassed. When healing operation is completed, a request to cancel healing mode will be sent to Pure Ballast. Pure Ballast is now in standby again. In this example, healing mode is requested during deballast. First, a pop-up will appear, requesting you to stop the ballast pump. Stop the pump and then press Confirm Ballast Pump Stopped. On some vessels, this is handled automatically. If the pump is needed for healing, confirm the request without stopping the pump. The control valve will close to stop the flow in the ballast water line 201. The UV lamps will go to power saving mode and cooled with water from the cooling water line 403. A warning will be issued, notifying that healing mode has been requested. Press AC All to acknowledge the warning. Pure Ballast is now in healing mode, and the system will be bypassed. Notice that the pause and deballast button is yellow when the process is paused. If the system is in healing mode longer than what is set in parameter P138, the process will be stopped. When the healing operation is completed, a request to cancel healing mode will be sent to Pure Ballast. A pop-up will appear, requesting you to start the ballast water pump. Start the pump, and then press Confirm Ballast Pump Started. On some vessels, this is handled automatically. Press AC All to acknowledge the warning. The deballast process will now continue. After a process, a SIP cleaning should be started to clean the UV reactor. To start a SIP cleaning, press SIP. A pop-up will appear, requesting you to open overboard valves for the backflush pipe 309 and the SIP drain pipe 460. These valves cannot be opened from the Pure Ballast control system. Also make sure that valves leading technical or potable water to pipe 310 are opened. Open the valves and then press Confirm Open Valves. On some vessels, this is handled automatically. The SIP cleaning is now starting and it takes about 25 minutes per UV reactor to complete it. The UV reactors will be cleaned one by one and filled with technical or potable water. If the filter has been used, seawater is drained and the filter is filled with technical or potable water as the final step. Pure Ballast will go through the following sub-processes. These sub-processes will be repeated for every UV reactor. When the SIP cleaning is finished, a pop-up will appear, requesting you to close overboard valves for the backflush pipe 309 and the drain pipe 460. Close the valves and then press Confirm Valves Closed. On some vessels, this is handled automatically. After a SIP cleaning, the UV reactor and filter are preserved until the next process is started. As the first process is started, the SIP timer starts to count down. The next SIP cleaning must be performed within 30 hours from the first process. It is possible to run several processes, if it is within the time limit. If a SIP cleaning is not performed before the timer runs out, a warning will be issued and an entry is made to the log file. Any operation after the 30 hours time limit is non-compliant. Detailed information about the SIP cleaning is displayed on page 1.3. In the flowchart for the SIP module, it is possible to see the status for valves and pumps and follow the flow. The SIP status displays the current process and sub-process. The status for each UV reactor is displayed here. A green box indicates that the SIP cleaning is finished. A white box indicates that there are no SIP errors. A red box indicates that there is an active alarm that needs to be attended to before a process can be started. A yellow box indicates that a SIP cleaning is required and the timer indicates when, at latest, this must be done. If SIP cleaning is not performed before the timer runs out, an alarm will be issued and an entry is made to the log file. A SIP cleaning must be performed, otherwise the next process will be non-compliant.
Click Next to continue. You have now come to the end of Topic 3, Process Description. Click Next to go back to the menu. The Pure Ballast 3 system can be controlled in 3 ways: through the Main Control Panel, located on the Control Cabinet. Remote Control Panel. Installing the Remote Control Panel is optional. If required, 1 or 2 panels can be installed. The interface of the Remote Control Panel is the same as the Main Control Panel. Remote Interface. The remote interface is integrated in the ship's control system, ISCS. This integration is customized for each vessel and is, therefore, not covered in this training module. Please refer to the Remote Interface Implementation Guide for more information. Click Next to continue. To operate Pure Ballast 3, you must first log in. There are different login levels, and each has a different authority. The system can only be controlled from one panel at a time. To switch commands from one panel to another, you must log in to the new panel with the same or higher login level in the active control panel. Click the play button to understand how to log in.
To log into the Pure Ballast control system, press Log In. Open the drop-down menu. As you can see, there are 4 different login levels. Guest is the default level and is not password protected. As a guest, you can view all pages. As an operator, you can view all pages and perform daily routines. For example, starting a process and acknowledge alarms. An operator has full access to page 1.4 Power Request and can download log files and backups to a USB memory. As an advanced operator, you have the same authorities as operator, but you can also operate the equipment in manual mode, set non-critical parameters, and have full access to page 4.3 operation timers. The Alfa Laval login level gives full access to all parameters and settings. This login level should only be used by Alfa Laval personnel. Choose Login Level and select it. Enter password and press Login or Enter. The passwords for Operator and Advanced Operator can be found in the system manual. To log out, press the Login button and then press Log Out. Make sure to log out after the Advanced Operator or Alfa Laval level has been used, to avoid changing any parameters by accident and risk of running a non-compliant operation.
Click Next to continue. Let's explore the interface of the Pure Ballast 3 system. The interface consists of tabs. The top and side tabs are used to choose the page to be displayed on screen. Click on each highlighted area to learn more. The top tabs contain the main function areas of the control system: Overview, Alarm Lists, Trend Indication, System Information and Parameters. The side tabs contain subpages for the selected area in the top tab. Click Next to continue. Pop-up windows are used to display or enter detailed information. Click on the filter and UV reactor to know more. On clicking Filter, the filter pop-up is displayed. On clicking UV reactor, the UV reactor pop-up is displayed. Click Next to continue. Function buttons are used for the main processes and control of the system. They are placed at the bottom of the screen and are always visible. If a function button is grey, it is inactive. This inactive state does not allow you to press the button. Click on Start to know more about the function buttons. ballast button starts the ballast process. The deballast button starts the deballast process. The stop button stops the current process. The strip button starts the tank stripping process. It also resumes the paused process. The pause button pauses the ballast, deballast or stripping processes. The sip button starts the sip process. The local button activates the operation from Pure Ballast's control panel. The remote button activates the operation from the remote interface, if installed. The manual button sets the control system in manual mode, which enables manual operation of the system and its components. The button is displayed for advanced operator or higher login levels. The IMO button sets the control system in the IMO mode, which activates operation in accordance with the IMO requirements. The USCG button starts the control system in the US Coast Guard mode, which activates operation in accordance with US Coast Guard requirements. The text below the button indicates if the system is run as USCG 0 days hold time or USCG 3 days hold time. Hold time is selected in parameter P182 in the main parameters page. We will visit that page later in the module. The wipe button disables the touchscreen function for 10 seconds to make sure it is possible to clean the screen without the risk of starting a process or changing a setting. The night button activates the night light for the panel. Night light makes the panel less bright. The Utilities button enables the print screen function. Click Next to continue. Apart from buttons, the Pure Ballast 3 system also has status indicators. These indicate the active state of the system. Status is also indicated through button color, button light. Click on each button to know more. The color of the buttons indicates the various statuses of the Pure Ballast 3 system. Buttons appearing in blue indicate that the function is enabled. Buttons appearing in light blue with a check mark indicate that the function is activated. Buttons appearing in grey indicate that the function is disabled. After a function button is pressed, a light under the button is lit to indicate the status for the activated function. Green light indicates that the command is active. Yellow and blinking light indicates that the command is paused. A light under the button in pumps or valves indicates the component status. Grey light indicates that the component is closed or not running. Green and blinking light indicates that the component is travelling or starting. Green light indicates that the component is open or running. Red and flashing light indicates an active alarm for the component. Click Next to continue. The interface of the Pure Ballast 3 system displays an overview of the system, the overall status, and detailed information about the components. The status box displays the status for the Pure Ballast 3 system. Click on Start to know more about the status box. In the status box, Process displays information about the ongoing process. The sub-process displays information about the sub-steps of an ongoing process. An example is the startup procedure during the ballast process. If freshwater is processed in the IMO mode, FW is stated after the sub-process. Time displays information about the remaining time for the ongoing sub-process. Processed volume displays information about the amount of water processed during the ongoing process. Power consumption displays information about the power consumption for the ongoing process. Certified flow displays the maximum allowed flow for the selected operation. It is the flow that the system is aiming to keep. Current flow displays the current flow indicated by flow transmitter FIT 2011. Flow selection displays information about the flow in cubic meter per hour selected for the operation. Flow can be selected manually or automatically. Ballast pump indicates the status for the ballast water pump. It is not part of Alfa Laval's scope of supply. Overboard valve or valves indicate the status for overboard valve or valves and other valves involved in a process. Click Next to continue. Apart from the function buttons and the status box, the interface of the Pure Ballast 3 system also shows a flowchart. It displays a schematic overview of the Pure Ballast 3 system and its components, relevant information regarding the ongoing process and component status, pressure, flow and control valve opening. Click Next to continue. The flowchart includes the SIP unit. On clicking this unit, the SIP status for all UV reactors is displayed. Click the highlighted component to learn more. The SIP interface includes the following elements: SIP status, SIP UV reactor information, SIP module flowchart. Click on Start to know more about the SIP status page. The SIP status box displays the status for the Pure Ballast 3 system. The SIP UV reactor information displays the SIP status for each UV reactor. Each row displays the SIP status for every installed UV reactor, if applicable. This row indicates the status and time for the filter preservation process that starts after a completed SIP. During filter preservation, the SIP fills the filter with technical water or potable water for preservation purpose. This row indicates the total estimated time for a completed SIP process, including filter preservation. If the SIP error column displays white, it means that there is no active alarm regarding the SIP. If the SIP error alarm column displays red, it means there is an active alarm. You need to check the alarm list from the manual to know more. If the SIP column displays yellow, it means that SIP is required. If the SIP column displays yellow and is blinking, it means that the SIP process is ongoing. If the SIP column displays green, it means that SIP is completed. If the SIP column displays white, it means that SIP is required but cannot be performed due to an active alarm on the UV reactor. Status column displays the status of the UV reactors and the filter. Estimated time column displays the estimated time to complete SIP cleaning of the UV reactors or the filter. The SIP process takes about 25 minutes per UV reactor if the default parameters are used. The SIP required is the time before a SIP process must be started. The SIP timer will start to count down 30 hours from the first operation after the previous SIP process. If no SIP process is performed within the time limit, an entry is made in the control system's log file. Operations after the warning do not fulfill the type approval certificate. The SIP module flowchart displays a schematic illustration of the SIP module with status for the valves and pumps. Click Next to continue. The alarm list page displays active alarms and warnings. Click on Start to know more about the alarm list. Alarms stop the ongoing process, which can be restarted after the problem has been attended to. Warnings notify a status change, requests for action, or a problem that must be attended to. A warning, however, allows the process to continue. Apart from active alarms and warnings, the alarm list has a few more functions. The AC All button acknowledges all alarms in the list. When an alarm or warning is inactive and acknowledged, it is moved to Alarm History. On clicking the Alarm History button, the alarm history is displayed. This page displays a list of inactive and previously acknowledged alarms and warnings. Click Next to continue. An alarm or warning displays different colours depending on their status. Red indicates an alarm is active. Pink indicates that though the alarm has been acknowledged, it is still active. Orange indicates the warning is active. Yellow indicates that though the warning has been acknowledged, it is still active. For detailed information about alarms and warnings, please refer to Chapter 5, Alarms and Fault Finding of the manual. Click Next to continue. The System 1 page in the Pure Ballast 3 system interface is used to display the status information for the control system and the control panel. It is also used to back up information and restore information from a backup. The information here is useful when communicating with Alfa Laval to get the adequate support. For example, you can see the PLC software version here. Click on the highlighted area to know more. Export log files is used to extract the information regarding the operational history of the system. The log files can be read and analysed in the software Visual Log. Click on the Play button to understand how to export log files. Click on the Play button to understand the Visual Log software.
Events and alarm history are logged in the control system and stored for at least 24 months. If the log box is installed, the log also includes components connected to the log box. The log files will not be deleted from the PLC during export. A list of all events that are logged can be found in the system manual under List of Logged Information. The log files are stamped with the system name and serial number entered in page 5.6. To export the log files, go to page 4.1. Press the Export button. Insert a USB memory into the USB PLC port. The default start date is the oldest file in the control system, and the default end date is today's date. This is the recommended time interval, but it is also possible to specify the time interval. Press the Events button. The information is now copied to the USB memory. Wait for the message Export OK to appear. Press the Alarms button. Wait for the message Export OK to appear. Press Close and remove the USB. Alfa Laval's Visual Log is a software used to read and analyze the log files from the control system. With Visual Log, you can easily troubleshoot alarms, warnings, and events and create reports. Contact your local Alfa Laval sales office to obtain the software. Start by adding the Visual Log folder to your computer. The folder contains release notes, installation and operation manuals, and the installation and configuration files. To install Visual Log, follow the installation and operation manual. After installation of Visual Log, insert the USB with the log files from the Pure Ballast system to your computer. There should be two files, one for alarms and warnings and one for events. Copy the files to your computer. Open Visual Log. Go to Pure Ballast, Reports, and then select Pure Ballast. Select on the log files and import them. The name of the log files will appear here. Clicking Clear will remove the log files. Make sure that Preview All Files is on, otherwise not all data rows will be visible. Some events are as default hidden and will only show if this box is checked. The data from the log files can be seen here. Click on the arrows to browse through the logs. The active time is when the data was created. The severity level can either be event, warning, or alarm. The ID and description of the data can be seen here. The ID starts with an E if it's an event, W if it's a warning, and A if it's an alarm. If a GPS is installed, it's possible to see the coordinates on where the data was created. Some of the events have a value, for example, treated ballast water, and it will show up under Value and Unit. The system name should be the vessel's IMO number, and the serial number should be the order number. The software version is the version of the software in Pure Ballast control system. To search within a column, just type a search word here, for example, deballast. Do not forget to empty the field again when you want to see all your data. If you click on the filter icon, you can add more advanced filters. It's also possible to search within all columns through this search field. To filter on date, go to the date range and select Start and End Date. Click Apply. To remove the filter, press Reset. With the Report tool, it's possible to create reports on your ballast water operations. The reports can, for example, be used at port state control inspections together with your ballast water records. In this example, we'll create a report on when and where the Pure Ballast system was bypassed. Start by filtering on the event code E350. Bypass valve is open. To generate a report, click in Export as PDF. Wait until the report is generated, then click on the I to view it. To be able to print the report, click on Download to save it as a PDF on your computer. Then open the PDF and print it.
Click Next to continue. The Main Parameters page of Pure Ballast 3 System describes the main system parameters. Most parameters on this page are set at commissioning and should only be changed by Alfa Laval's service engineers, except for P182. When operating in the US Coast Guard mode, the operator needs to select the hold time, 0 days or 3 days. This is set in parameter P182. For more information about what to consider when choosing between different modes, refer to the e-learning course Pure Ballast 3 Operation. Click Next to continue. The Installation Parameters page describes the installation-specific system parameters. Most parameters on this page are set at commissioning and should only be changed by Alfa Laval's service engineers. The system name should be set to the IMO number of the vessel. The Pure Ballast 3 serial number, starting with PB, can be found on the system plate on the electrical cabinet. The system name and serial number will be displayed in the event log and alarm list when exported from the control system. We have now reviewed the most frequently used pages for everyday operation. You can find additional information about the other pages in the system manual. Click Next to continue. You have now come to the end of Topic 4, the control system. Click Next to go back to the menu. Here are the key concepts you learned in this module. Click each key concept for a recap. Alfa Laval Pure Ballast 3 is an automated inline treatment system that disinfects ballast water by using filtration and ultraviolet technology. The ballast water must be treated during both ballast and deballast. Before starting a process, the operator must choose the mode, IMO or US Coast Guard, depending on current location and destination. To facilitate the monitoring and control of Pure Ballast 3, it is possible to integrate the control system with other components on board the vessel. The following integrations are available: Remote Interface, ISCS, Remote Control Panel, Power Management, External Feed Control, GPS, Common Alarm, Logbox, Pure Ballast Connect, Component Signals. The ballast water treatment involves the following processes: ballast, deballast, stripping, healing, and sip process. The most frequently used pages for everyday operation consist of the following elements: tabs, pop-up windows, function buttons, status indicators, status box, flowchart, the SIP interface, SIP status, SIP module flowchart, alarm list, system info page, main parameters 2, installation parameters. The Pure Ballast 3 system has two process modes: IMO mode and US Coast Guard mode. The US Coast Guard mode has two hold times, 0 days or 3 days. Pure Ballast 3 includes the following components: control cabinet, filter, UV reactor, lamp drive cabinets, flow meter, control valve, SIP unit, sampling device, bypass valves. The optional components include the following: booster pumps, closed cooling unit, vacuum relief valves, air preparation unit, transformer. Pure Ballast 3 can be controlled in three ways: through the main control panel located on the control cabinet, through the remote control panel. This is optional. If required, 1 or 2 remote control panels can be installed. Through the remote interface. This is optional. It is used in the integration of the ship's control system, ISCS. Click Next to continue. You have now come to the end of Topic 5, Summary. Click Next to go back to the menu. You have nearly come to the end of this e-learning module. By now, you have learned in detail about Alfa Laval's Pure Ballast 3 automated inline treatment system, its system components, and ways to operate it. How about a short quiz to check your understanding? We will not test your knowledge on the optional components, as these can differ for vessel to vessel. What to expect? In the following screens, you need to attempt 10 questions. These include multiple choice questions and fill in the blanks. What we expect from you: you need to score at least 80% to pass the test and successfully complete the course. If you fail to score the minimum percentage, you need to retake the test. You can retake the test as many times as needed to get the required score. So, are you ready? Let's proceed. Click Next to continue. Every year, about 3 to 5 billion tons of ballast water is moved around the world. Every day, over 7,000 species of plants and animals are transported to different ecosystems. Some of these invasive species cause harm to existing species and destroy ecosystems. Did you know? The warty comb jelly introduced in the Black Sea destroyed the anchovy fishing industry. The zebra mussel introduced in the Great Lakes via ballast water damaged the ecosystem. Here is where Pure Ballast can make a difference. Alfa Laval's Pure Ballast adheres to international regulations and helps prevent marine pollution arising out of shipping. thus protecting the marine ecology. Welcome to the e-learning module on Alfa Laval's Pure Ballast operation. This training will take you approximately 60 minutes to complete. The training is in English. Click Begin to start the course. Please take a moment to get used to the navigation features. They are located at the middle bottom of your screen. Hover with your mouse over the buttons to see their functionality. This module has 5 topics. We recommend that you view these in sequence. To successfully complete this module, we request you to visit all the screens. Click on each topic to learn more. Alfa Laval's Pure Ballast is about protecting the environment. The Ballast Water Management Convention requires all vessels to install a ballast water treatment system. The Pure Ballast helps customers comply with the regulations set by both the International Maritime Organization, IMO, and the United States Coast Guard, USCG. The IMO has set guidelines to carry out ballast water management procedures. The US Coast Guard has rules for vessels entering US waters. This training module will help you understand how you can adapt to these regulations and comply with the legislations. This training module will help you understand the differences between IMO and US Coast Guard modes, understand how to stay compliant, recognize the best practices on operations. You have now come to the end of Topic 1, Introduction. Click Next to go back to the menu. The IMO and US Coast Guard discharge standards are identical, but the testing and verification methods used to measure the effectiveness of the ballast water treatment system are different. Click each button to learn more. The IMO evaluates how many organisms that can reproduce, that is, viable and non-viable organisms. If the organisms cannot reproduce, they do not pose a threat of becoming invasive. The US Coast Guard, on the other hand, evaluates how many organisms are living and non-living. A higher UV dose is needed in order to categorize the organisms as non-living directly after the discharge treatment, compared to rendering them non-viable. Therefore, the Pure Ballast system has 2 operational modes, IMO and US Coast Guard, that have been adapted to the legislations to optimize the performance of the ballast water treatment system. These different modes are compliant with regulations in the USA, US Coast Guard mode, or in the rest of the world, IMO mode. Click each button to learn more. The IMO mode is used for ballasting when the destination port is outside US waters, and deballasting if the current location is outside of US waters. The IMO mode can also be used if the vessel has an AMS, or annual maintenance contract, and is operating under an extended compliance date authorized by the US Coast Guard. The US Coast Guard mode is used for ballasting when the destination port is within US waters, regardless of the starting point, and deballasting within US waters. Roll your mouse cursor over the map for an enlarged view. The ballast water must be treated by the Pure Ballast system during ballasting, deballasting and stripping. Before starting a process, the operator must choose if the operation shall be run in IMO or US Coast Guard mode, depending on current location or destination. Remember, for the US Coast Guard mode, consider the hold time, that is, how long the ballast water will be kept in the tank before it is discharged. When using US Coast Guard mode, you must also choose 0 days or 3 days. The purpose of holding the ballast water in the tank is to secure that all organisms are rendered non-living before the ballast water is discharged. Hold time is set in parameter P182 in the control system. Here's how the hold time looks in the US Coast Guard mode. Click each button to learn more about the hold time. The time between completing a ballast process and starting deballasting or stripping must be at least 2.5 hours. The time between completing a ballast process and starting deballasting or stripping must be at least 72 hours. From this point in the module, we will refer to water treated with IMO mode as IMO water, and the water treated with the US Coast Guard mode as US Coast Guard water. The ballast water record book is used to keep track of the mode used to fill the ballast water tanks. How this is done should be stated in the ballast water management plan. Though it is not recommended to fill the ballast water tanks using different modes, if that happens, the following will apply. Click on each icon to learn more. If IMO water is mixed with US Coast Guard water, the water in the tank must be considered as IMO water. The water is allowed to be discharged in an IMO port using any mode of operation. If US Coast Guard 0 days water is mixed with US Coast Guard 3 days water, the water in the tank must be considered as US Coast Guard 3 days water. The water is allowed to be discharged in a US Coast Guard port using US Coast Guard 3 days mode, if the water in the tank is held for 72 hours. Now that you know a little about the operational modes, how about a quiz? You are travelling from Marseille to Rotterdam, and then to New York in USA next. You plan to ballast in Marseille and then deballast the water in the next 2 ports. Which of the modes would you apply in these locations? Drag and drop the modes next to the locations and click Submit. You are travelling from New York to Brunswick. The travel time is less than 72 hours. You plan to ballast in New York and deballast the water in Brunswick. Which of the modes would you apply in these locations? Drag and drop the modes next to the locations and click Submit. You are travelling from Brunswick to Los Angeles. The travel time is more than 72 hours. Next, you are travelling to Australia. You plan to ballast in Brunswick and deballast the water in the next 2 ports. Mark the statements as true or false and then click Submit. If you want to be sure that you can deballast in all ports, which mode should you choose when ballasting? Select the option you think is correct and click Submit. Half of the ballast water tank is filled with US Coast Guard 3 days water. You fill up the tank with IMO water and hold it for 3 days. Which statement is correct? Select the option you think is correct and then click Submit. The Pure Ballast system automatically regulates the flow and power to the lamps depending on the water clarity. When the water clarity is high, the lamp power is reduced to save power. On the other hand, when the water clarity is low, the flow is reduced to ensure full treatment of the water. The flow and power are reduced depending on the water clarity and also based on the mode being selected: IMO, US Coast Guard, 3 days, US Coast Guard, 0 days. The water salinity. UVI is the total amount of light reaching the UVI sensor. During a ballast or deballast process, the UVI value is measured to secure that the organisms in the water are treated with a sufficient UV dose. The higher the water clarity, the easier it will be for the UV light to be absorbed by the organism. High water clarity is related to a high UVI value. However, the UVI value is also related to the condition of the internal components in the UV reactor: the quartz sleeves, the UV lamps, and the UV sensor. If scaling or fouling has occurred to any of these components, it will lower the UVI value, since less light will be able to reach the sensor. When the UVI value falls below the compliance limit, the operation continues but does not comply with the legislations. A warning and a common alarm signal are issued, and an event is written to the event log. The operator follows the ballast water management plan and chooses to stop the operation or continue it and not comply with the legislations. Let's now look at the correlation between UVI value and flow control and power optimization. The system manual will provide more information on the actual values of the compliance limits. It will also help you understand at which UVI values flow control and power optimization occur at different modes. Click on each UVI value to learn more. Flow control and power optimization are not active at the following conditions: in the sub-processes of startup, pause and stop, during stripping, if a UV lamp breaks. In stage A, that is at low UVI values, the flow of water is reduced to maximum 50% of maximum flow, and the UV lamps are lit to 100%. In stage B, that is at moderate UVI values, the flow of water is 100% of the maximum flow, and the UV lamps are lit to 100%. In stage C, that is at high UVI values, the flow is set to be 100%, and the lamps are dimmed down to maximum 50%. What happens in the event a UV lamp breaks? If a UV lamp breaks during operation, the ongoing process continues, but it is not compliant. Click on each icon to find out more. The flow is reduced, and the UV lamps are lit to 100%. A warning and a common alarm signal are issued, and an event is written to the event log. The operator should act according to the ballast water management plan. After the process is finished, it will not be possible to start a new process until the broken lamp has been replaced. Now that you know about flow control and power optimization, how about an activity? Can you identify which of the following statements are true? Select the option you think is correct, and then click Submit. Here's another question for you. You run a ballast operation when you notice that the water flow has reduced. What could be the reason for this? Select the options you think are correct, and then click Submit. You have now come to the end of Topic 2, Operational Modes. Click Next to go back to the menu. Captain Oliver is soon to dock his ship and is approaching a port. He is in a dilemma. Oliver has to discharge the non-compliant ballast water and is fully aware that he would not be complying with the rules. Can you help Captain Oliver by arranging the actions in the correct sequence? Drag and drop the number next to the action and then click Submit. A trained crew is one of the requirements for staying compliant, to use the Pure Ballast system in a safe and correct way. Service, maintenance and calibration should be done regularly as per the maintenance schedule in the system manual. Meet Lucas. Lucas is a deck officer on a cargo carrier. He is about to start a ballast operation. When doing a ballast operation, it is important that he chooses the appropriate legislation mode for his destination port. Lucas needs to take notes on which legislation mode IMO or US Coast Guard, has been used to fill respective tanks. In US Coast Guard mode, he also needs to note which hold time mode has been used. Lucas should also be aware of how long the water will be stored, 0 days or 3 days. What's more, he needs to consider the legislation mode during deballasting. Even a very small amount of untreated water, a few hundred litres, can contaminate a ballast tank. A contaminated ballast water tank contains living organisms, and this will cause a water sampling test to fail. What are the risks that can lead to contamination in a ballast water tank? Here are the risks that can lead to a contaminated ballast water tank. Click on each icon to learn more. Leaking valves, if there is untreated water present in the piping. Internal transfer between tanks, if untreated water is present in the piping. Sediment in tanks, since sediment is a breeding ground for organisms. Review the ballast water management plan regarding frequency of sediment removal. The Pure Ballast system issues a warning if you risk running a non-compliant operation. It is important that you attend to the problem as soon as possible. When troubleshooting the warnings, refer to the troubleshooting table in the system manual. Let's look at the examples. Click on each image to learn more. For safety reasons, it must be possible to bypass the Pure Ballast system if it malfunctions. The system must be equipped with at least one bypass valve, according to the International Convention for the Control and Management of Ships' Ballast Water and Sediments 2004. The valves must be controlled by the control system of the vessel, not Pure Ballast control system. All bypass valve activities are logged in the event log. There can be several combinations of valves that can be used to bypass the system, that is, referring to the coloured lines. One line is one combination of valves that can enable a bypass, both driven by pumps, red and purple lines, and by gravity, green, yellow and blue lines. Monitoring can be done via the remote interface, logbox, or be hardwired directly to control cabinet. Refer to the respective installation guide for more details. If the Pure Ballast system malfunctions in connection with general cargo operation, ballasting and deballasting should be avoided if possible. The procedures concerning emergency and malfunction of the ballast water treatment system should be implemented in the ballast water management plan. Roll your mouse cursor over the diagram for an enlarged view. What should you do first if you are entering a port to take on cargo and your ballast water has not been treated in the proper legislation mode? Select the option you think is correct and then click Submit. Which of the following events will not issue a warning that is logged in the event log in the Pure Ballast control system? Select the option you think is correct, and then click Submit. What should you do first if a warning is issued? Select the option you think is correct, and then click Submit. You have now come to the end of Topic 3, Compliant Operation. Click Next to go back to the menu. In all open pipe designs, it is important to reduce the existence of air pockets by priming the piping. Priming during ballast and deballast is needed in order to prevent the pure ballast system from experiencing excessive forces due to pressure waves. We recommend you to update the Ballast Water Management Plan, or BWMP, according to these guidelines, to ensure that the system is operated in the best way at every operation, regardless of the operator. The flow from the ballast water pump should be adjusted at the start and stop of ballasting or deballasting to allow a soft start and stop. Although using a speed-regulated pump is preferred, for example, by a VFD, you can also use a static pump in combination with a throttle valve. Note that the flow should never be less than the flow requirements stated in the system manual to secure cooling of the UV lamps and efficient backflushing during ballasting. Follow these steps. Start the ballast water pump at low flow to fill the ballast main line. When the ballast main line is filled and air is removed, gradually increase the flow to 100% of certified flow. Follow these procedures to allow a soft start. Click the Simulation button to start the simulation. In this example, the pure ballast is operated from the control cabinet. If installed, pure ballast can also be operated remotely from a control panel or from the vessel's control system. A pure ballast 3.2 standard system is used in this example. The procedure is the same for EX, Compact and Compact Flex systems. It is only the interface on the control panel that is different. Press Ballast. When requested by Pure Ballast, open overboard valves and then press Confirm. On some vessels, the action will be confirmed automatically and the operator does not need to press the Confirm button. This applies for the following confirmation pop-ups as well. Press Confirm Open Valves. On clicking the Confirm Open Valves button, the pop-up disappears. The ballast water pump should be started at low flow. Note that the flow should never be less than the flow requirements stated in the system manual to secure cooling of the UV lamps and efficient backflushing during ballasting when requested by Pure Ballast. Ensure that the ballast piping is filled with water and air removed. When the pump is started at low flow, press Confirm Ballast Pump Started. Then, on clicking the Confirm Ballast Pump Started button, the pop-up disappears. The Pure Ballast system is now in full ballast mode. Follow these procedures in order to allow a soft stop. Click the Simulation button to start the simulation. When you are ready to stop the ballast process, slowly reduce the flow from the ballast water pump. How much of the flow should be reduced is specific for each vessel and depends on the capacity of the ballast water pump, but 30% of the pump capacity is suggested. However, note that the flow should never be less than the flow requirements stated in the system manual. When the flow has been reduced, press Stop. When requested from Pure Ballast, stop the ballast water pump. Then press Confirm Ballast Pump Stopped. On clicking the Confirm Ballast Pump Stopped button, the pop-up disappears. When requested by Pure Ballast, close the overboard valves and then press Confirm Valves Closed. On clicking the Confirm Valves Closed button, the pop-up disappears. The Pure Ballast system will, after it has cooled down, go to standby mode. Shallow or muddy water with a high dirt load, such as that of Mumbai, India, or the Yangtze River in China, puts many ballast water treatment systems to test, and some vessels have experienced problems with filter performance. However, with the right equipment and knowledge, these issues can be avoided. How important is a filter in the pure ballast system? The filter plays a vital part in the pure ballast system as a first treatment step before the water is treated by UV light in the UV reactor. When the filter is in use, sediments will start building up on the filter. This increases the differential pressure between the filter inlet and outlet, which will trigger an automatic backflush, which cleans the filter. The backflush water is discharged overboard. There is no risk of pollution by invasive species, since the filter sediments are discharged in the same local area as it is collected from. Take a look at this video to understand this process better. Click the play button to start the video.
Filtrex ACB is an automatic backwashing filter for water operated by electric power. Cleaning is performed using the filtered water with no interruption in the filtration process. The water enters from the inlet connection and flows through the wire mesh sectors of the filtering element. The water, filtered from inside to outside, exits through the outlet connection. During this phase, the filter operates as a static filter and the cleaning of the filtering element is inactive. As more and more impurities build up in the filtering element, the differential pressure gradually increases, as shown by the indicator, until the programmed set point is reached. Through the control panel, the electric motor is activated, then the backwash valve is opened, starting the rotation of the cleaning nozzle and the cleaning phase. While all sectors of the filter element ensure the normal filtration from inside to outside of the filtering element, the sectors in front of the rotating nozzle are rapidly cleaned one by one, with a reverse flow from drawn outside to inside of the filtering element. Thanks to the suction effect generated, the impurities are transported by the flow in the backwash line through the sludge duct and the backwash valve for disposal. At the end of the cleaning set time, the backwash valve closes and the motor stops, returning the filter to the static phase. The cleaning cycle is repeated every time the pressure drop reaches the preset value. The filtration process never stops.
The backflushing does not interrupt the ballast process, since only a small part of the ballast flow is used for backflushing. If a new backflush is triggered within 2 minutes, the filter will go into continuous backflush for 20 minutes. If the differential pressure still is too high, the backflushing will continue until the pressure becomes lower. In muddy water, the filter will most likely go into continuous backflush, but this is completely normal and means that the filter is working the way it should. To ensure that the filter is in optimal condition, service and maintenance work should be carried out regularly, as per the maintenance schedule in the system manual. You should also follow these recommended procedures before, during and after operation. Click on each text to learn more. Before entering a high dirt load water zone, backflush the filter in the open sea to ensure the filter is fully cleaned on arrival. Confirm that automatic backflush is operating correctly by ensuring backflush nozzle is rotating freely. Filter deaeration valve is working correctly. Backflush valve can be opened and closed properly. Backflush pressure is at filter inlet according to System Manual 1.7 bar. During operation, confirm that overboard valves are open. Use the upper sea chest in shallow water to prevent picking up mud and particles. Reduce the flow during ballast to reduce the stress on the filter mesh. After operation, do several backflushes in open water to clean the filter thoroughly. If needed, clean the filter manually. Start a SIP cleaning process to clean the system and preserve the filter for the next operation. If you are still experiencing a problem, you should confirm that the backflush pump rotational direction is correct. Confirm that the backflushing parameters are set according to the system manual. The parameters should normally not be changed after commissioning, but can, if needed, be adjusted for specific circumstances. Alfa Laval shall be consulted before changing the parameters. Click the button to learn more. Sometimes, the number of particles being pumped into the vessel could be more than the filter can handle, even with continuous backflushing. What should you do? In such a scenario, if the pure ballast system would malfunction, refer to the ballast water management plan and follow the contingency measures. The pure ballast system can process ballast water in temperatures between -2 and 40 degrees Celsius in liquid form. To reduce the risk of getting ice in the piping and ballast water tanks, it is recommended that you use the lower sea chest, which takes up less ice. Gravity operation, not using the ballast water pump, can only be allowed if the following prerequisites are fulfilled. The requirements for flow and backflush pressure are fulfilled. The vessel's flag state and classification society allow gravity operation. Gravity operation is stated in the vessel's approved ballast water management plan. Now that you know what the best practices on operating the pure ballast are, how about a quiz? Which sentence is true about filter backflush? Select the options you think are correct, and then click Submit. Here are two statements about ballasting in different waters. Drag and drop the items in the correct slots and click Submit. During a ballast operation, the filter goes in a continuous backflush. What should you do? Select the option you think is correct, and then click Submit. You have now come to the end of Topic 4, Best Practices. Click Next to go back to the menu. Here are the key concepts you learned in this course. Click each key concept for a recap. The pure ballast system has two process modes, IMO and US Coast Guard. The US Coast Guard mode can be used with two different hold time modes, 0 days or 3 days. The ballast water must be treated during both ballast and deballast. Before starting a process, the operator must choose if the operation shall be run in IMO or US Coast Guard mode, depending on current location or destination. Make a note on which type of water, IMO or US Coast Guard, is stored in respective tanks, and for how long it has been in hold in the tank, 0 days or 3 days. The pure ballast system will automatically regulate the flow and power to the lamps, depending on the water clarity. The lamp power is reduced to save power when the water clarity is high, and the flow is reduced to ensure full treatment of the water when the water clarity is low. If a UV lamp breaks during operation, the ongoing process continues but is not compliant. The flow is reduced and the UV lamps are lit to 100%. If a lamp breaks in standby mode, it is not possible to start a process until the broken lamp has been changed. A trained crew is one of the requirements for staying compliant, since it is important that the pure ballast system is used in a safe and correct way. Service, maintenance and calibration should be done regularly, according to the maintenance schedule in the system manual. The pure ballast system will automatically regulate the flow and power to the lamps, depending on the water clarity. The lamp power is reduced to save power when the water clarity is high, and the flow is reduced to ensure full treatment of the water when the water clarity is low. Ensure that the filter is in optimal condition. Carry out service and maintenance work regularly, as per the maintenance schedule in the system manual. Follow the best practices for operation as outlined in the training module. Even a very small amount of untreated water, a few hundred litres, can contaminate a ballast tank. A contaminated ballast water tank contains living organisms and will cause a water sampling test to fail. The pure ballast system issues a warning if you risk running a non-compliant operation. Attend to the problem as soon as possible. When troubleshooting the warnings, refer to the troubleshooting table in the system manual. The pure ballast system is equipped with one or several bypass valves to be able to bypass the system if it malfunctions. The system should only be bypassed if stated as a contingency measure in the ballast water management plan. You have now viewed all the topics in the course. Click Next to go to the course completion screen. You have now successfully completed the e-learning module on Pure Ballast Operation. Please enter your name and click the Print Certificate button to download your certificate. Click Close in the browser to exit the course. Good service and maintenance helps maximize the performance of Pure Ballast 3. By following the procedures outlined in this training, you will reduce operating and maintenance costs and help prolong the system lifetime. As ship crew, we also encourage you to follow safety guidelines of the company you work for, as well as the regulations that apply locally. The Alfa Laval service team is available 24/7 and wherever you sail, by phone, online or on board. In this module, you will learn about basic safety rules, service and maintenance, and how to get support from Alfa Laval. Welcome to this e-learning module on Alfa Laval's Pure Ballast 3, Service and Maintenance. This module will take you approximately 15 minutes to complete and is in English. Click Begin to start the module. Let us now take a quick look at how you can navigate through this module. Click Next to continue. This module has 5 topics. We recommend that you view these in sequence. Click on each topic to learn more. Good service and maintenance are important to maximize the performance of your Pure Ballast 3 system. So, why is this training important? By following the procedures described in this training, you will reduce downtime and prolong the lifetime of the system. And, as a result, lower the operating expenses as well. By keeping the system in good condition, you will ensure that you stay compliant. Click Next to continue. As ship crew, there are some safety rules you must keep in mind. This training module will help you identify safety risks and the precautions you should take to avoid accidents. Recognize when and how calibration and maintenance must be carried out. Recognize how to troubleshoot alarms and warnings. Recognize what Pure Ballast 3 offers in terms of training and support, and how to contact Alfa Laval. Please note, always follow the safety regulations adopted by the company you are working for, as well as local regulations. Always read and follow the documentation that is included in shipment of components and spare parts regarding handling, safety and disposal. Click Next to continue. You have now come to the end of Topic 1, Introduction. Click Next to go back to the menu. Following safety rules helps you safeguard yourself from accidents or serious injuries. Here are some basic rules you should be mindful of. Read the applicable preparations and conditions carefully before you start a service. Only use Alfa Laval genuine spare parts. Use the correct safety equipment at all times. Click Next to continue. What are the different components you will handle when operating Pure Ballast 3, and what are the safety precautions for each? Click on each caption to learn more. The UV lamps contain a small amount of mercury, less than 0.2 grams per lamp, and must be handled with care and disposed of properly. Refer to the safety data sheet in the system manual for detailed safety information. If a UV lamp breaks, mercury can be released. Do not allow mercury to come in contact with your eyes or skin. Do not inhale mercury fumes. If mercury is released, decontaminate the area and dispose of the mercury according to national regulations. A mercury absorption kit can be used to collect the mercury. Talk with your local Alfa Laval sales office for more information. UV lamps and quartz sleeves are fragile and can easily get damaged. UV lamps radiate ultraviolet radiation when lit. Handle with care. Do not apply vibrations or shock to the UV lamp. This can cause breakage and shorten lamp life. Broken glass can also cause cuts. Always use protective eyeglasses and clean cotton gloves when handling UV lamps and quartz glass sleeves. Only operate the UV lamp when correctly installed inside the reactor, with end caps properly closed and the UV sensor properly installed. The lamp power supplies, or LPS, has a voltage of 600 volts inside and on the lamp power connector. Contact with voltage can cause severe injuries. Always make sure that the cabinet is shut down before the cabinet is opened. The SIP liquid is a weak organic acid that is classified as a skin irritant. Refer to the safety data sheet in the system manual for detailed safety information. Click Next to continue. You have now come to the end of Topic 2, Safety Precautions. Click Next to go back to the menu. Alfa Laval's Compliance Service Package has been designed to secure the system's compliance according to the final VGP 2013 and MEPC 279/70 regulations. The service includes system inspections, function checks, calibrations, crew training, and VGP 2013 water sampling, when applicable. Available in different packages, Alfa Laval's experts take responsibility for the health of your Alfa Laval Pure Ballast 3 system. To learn more, visit our website. Click Next to continue. Alfa Laval is an experienced supplier of ballast water treatment systems and has a global service network. Our service team is available 24/7 and wherever you sail, by phone, online or on board. Your local Alfa Laval sales representative is your primary point of contact, but for immediate support, contact our marine service team at marine.service@alfalaval.com or call our 24/7 service hotline at this number. Click Next to continue. With Pure Ballast 3 training, you get the knowledge to operate your Pure Ballast system in the best possible way. Our training courses are available on board your vessel, at our training facilities around the world, and digitally. To learn more, visit our website. Click Next to continue. You have now come to the end of Topic 4, Training and Support. Click Next to go back to the menu. Chapter 7 in the System Manual will provide you with the maintenance schedule, calibration schedule, as well as information about spare parts and such other technical information. Service and maintenance of the Pure Ballast 3 system must be carried out according to the recommended maintenance schedule in the System Manual to ensure performance, safety and durability of the equipment. Refer to the System Manual for step-by-step instructions for the service and maintenance procedures. Calibrate the sensors according to the calibration schedule in the System Manual to ensure performance, safety and durability of the equipment. Refer to the System Manual for information on the recommended spare parts to have on board. Use the spare parts catalogue to identify the correct spare part code. Only use Alfa Laval genuine spare parts. Communicate with Alfa Laval using the serial numbers on equipment. Refer to the System Manual for information about where the serial number is placed. Click Next to continue. If an error occurs, the Pure Ballast 3 will either issue an alarm or a warning. An alarm stops the ongoing process. You can restart a process when the problem has been attended to. A warning informs the operator about status changes or if a problem has occurred. A warning does not stop an ongoing process, but the task must be attended to as soon as possible. Consider whether the process should be terminated manually. The alarms and warnings will be displayed in the alarm list in the control panel. Use the troubleshooting table in the System Manual to troubleshoot the alarms and warnings. If a warning concerns non-compliant operation, this is stated in the warning. You should act according to the Ballast Water Management Plan. Let's now take a look at a video to understand how to attend to alarms. Click on the play button to view the video.
The Pure Ballast system has two types of alarms. An alarm stops the ongoing process. A process can be started when the problem has been attended to. A warning allows the process to continue, but the problem should be attended to as soon as possible. Consider whether the process shall be terminated manually. To troubleshoot the alarms, start by pressing AC All to acknowledge the alarms. Only the active alarms will remain, and they will change color to indicate that they are acknowledged, but still active. See the System Manual for detailed information about alarms and how to troubleshoot them. Troubleshoot one cause at a time. Press AC All to see if the problem is resolved. Some warnings, for example W140, indicate that the process is not compliant. Refer to the vessel's ballast water management plan for solutions for non-compliant operations. When all alarms have been attended to, the alarm symbol will be grayed out.
Click Next to continue. The system manual includes a USB memory, which contains tools that will be useful in daily operations as well as in service and maintenance. The USB includes digital copy of the system manual, PDF, how-to videos, Visualog. Click each tab to find out more. Add the system manual to your computer or other device so that you can always have it handy. Use the search function in your PDF reader to easily find the information you are looking for, such as alarm codes. Alfa Laval's how-to videos show how to perform service and maintenance of your Pure Ballast 3 system. For example, how to replace a UV lamp, dismantle the filter, and adjust valves. The videos also include operating instructions for processes like ballast, deballast, stripping, and sip cleaning. Visualog is a software that is used to read and analyze the log file exported from the control cabinet. The log files list all the issued events and alarms. In Visualog, you can create reports in a PDF format to certify that processes have been carried out in a compliant way. Click Next to continue. You have now come to the end of Topic 3, Service and Maintenance on Board. Click Next to go back to the menu. Here are some basic rules you should be mindful of. Read the applicable preparations and conditions carefully before you start a service. Use only Alfa Laval genuine spare parts. Use the correct safety equipment at all times. The system manual will provide you with the recommended maintenance schedule, calibration schedule, as well as information about spare parts and other technical information. Service, maintenance and calibration should be done regularly according to the maintenance schedule in the system manual. Click Next to continue. You have now come to the end of Topic 5, Summary. Click Next to continue. You have now successfully completed the e-learning module on Pure Ballast 3, Service and Maintenance. Please enter your name and click the Print Certificate button to download your certificate. Click the Close button in the browser to exit the module.